Now we'll do an example of a rational equation. To begin with a rational equation, our first move will be to find the least common denominator of all the fractions. If we examine our fractions and look to the first denominator, we see that it is a binomial. We also see we have another binomial in our other fraction. Because our fractions have two binomials in their denominators, the LCD for this equation will be both binomials multiplied together. And so we'll begin by saying the LCD is equal to x plus 1 times x minus 1. Our goal now will be to make each fraction have the LCD. Our first fraction has x plus 1 as its denominator. However, to make it match the LCD, it will need x minus 1. So we'll change that fraction to make it x over x plus 1, and we'll multiply on top and bottom times x minus 1. On the right side of the equation, we already have x minus 1. However, we will need x plus 1. So we'll write our 7 over x minus 1, but multiply on the top and the bottom by x plus 1. Now that we have our denominators all matching the LCD, we will now simplify our numerators by either distributing or using the FOIL method. In our first fraction, we will take the x times the binomial x minus 1, and this is an application where we would distribute. If we take x times x, we will get x squared, and x times negative 1 will give us minus x, still over the LCD. On the right side, we have another monomial 7 times the binomial x plus 1, and so once again we distribute. When we do so, we will have 7 times x to get 7x, and 7 times positive 1 to get positive 7. Again, all divided by the LCD, x plus 1, x minus 1. With our numerators simplified, what we'll do now is move all of the terms in the numerator to the left side. However, make sure that they do stay in the numerator. Also, make sure the denominator does not change. On our numerator, on our right side, we have 7x plus 7. We will move those to the left, and when we move them, they will become minus 7x and minus 7. This now gives us x squared minus x minus 7x minus 7 on our numerator. Our denominator does not change and stays as x plus 1 times x minus 1. Now, let's combine any like terms that we can in our numerator. The only like terms I can see in our numerator are the negative x and the negative 7x. Together, if you combine them, this will make negative 8x. So now we will have x squared minus 8x minus 7, all divided by x plus 1, all divided by x plus 1, x minus 1. Remember that this is now going to be equal to 0 because we moved all of our terms off of our right side and over to our left side. With that in mind, we will write two equations at this point. We will say that our numerator is equal to 0 and our denominator cannot equal 0. Therefore, we'll write an equation that says x squared minus 8x minus 7 must equal 0. And then for our second equation, we will write x plus 1 times x minus 1 cannot equal 0. The reason we write x plus 1 times x minus 1 cannot equal 0 is because we are not allowed to divide by 0 in a fraction, or else we'll get an undefined number. Technically, this x plus 1 times x minus 1 is not equal to 0 is not an equation. It is an inequality. However, our x squared minus 8x minus 7 equals 0 is a second power equation. In order to successfully solve this question, we must solve both the equation and the inequality. Let's begin with our second power equation. To solve this, let's use the quadratic formula. We will write our a, our b, and our c. Our x squared term has no number in front, so the a in our quadratic formula would be the invisible 1. The b would be the number in front of x, that's negative 8, and our c would be negative 7. We'll remind ourselves the quadratic formula is negative b plus or minus square root of b squared minus 4ac divided by 2a. When we place those three numbers into the formula, we will have negative of negative 8 is positive 8, plus or minus square root of negative 8 squared, which is 64, minus 4 times 1 times negative 7, all divided by 2a, which is 2 times 1. As before, we'll take a moment to simplify these terms inside of the square root. Negative 4 times 1 times negative 7 will give us positive 28, divided by 2 times 1, which is 2 on the bottom. This will give us 8 plus or minus root 92, all divided by 2. And then we'll have to think of a way to simplify square root of 92. Now, square root of 92 is a fairly large number, and so if you don't know what works on it, let's try dividing by perfect squares. If we try 92 divided by 4, if you put this into a calculator, you will end up with 23. Therefore, our square root of 92 we can split into square root 4, square root 23, which is the same as saying 2 root 23. When we split our fraction, we'll have 8 over 2 plus or minus 2 square root 23 divided by 2. If we cancel our 8 with our 2, we will end up with 4. And then the 2 in front of the root and the 2 on the bottom will cancel out directly. And so our solutions will be x equals 4 plus or minus square root 23. However, when you solve a rational equation, you need to make sure that none of your values disobey the inequality. So let's also look at the inequality. We have to make sure neither x plus 1 nor x minus 1 will give us 0. We're going to solve that inequality to find our restricted values. Therefore, in that inequality, we will say x plus 1 is not equal to 0, and x minus 1 is not equal to 0. We will take the positive 1 and move it to the right. When we move that positive 1 over, it will become negative, and we will have x is not equal to negative 1. If we do the same thing to the negative 1, we will move that negative 1 to the right, and it will become positive 1, and we'll have x is not equal to 1. These are your restrictions for your equation. However, the solutions that we came up with previously, that's 4 plus or minus square root 23, neither one of those gives us 1 or negative 1. Because neither of our solutions match our restrictions, we can be assured that both of our solutions are true answers. If any of your solutions were restricted values, they would be fake answers. Those fake answers would not be considered solutions to this problem because they are already restrictions. Therefore, it's important that when you solve a rational equation, you make sure that you know what the restrictions are before you write your solutions down. However, we verified that 4 plus square root 23 and 4 minus square root 23 do not give us plus 1, and they do not give us minus 1.